Now, let's talk about a variation of induction called strong induction. So the idea is still similar to the dominoes, but the domino analogy is a little different. So in ordinary induction, we think like this. If one domino falls, then it knocks over the next domino. So to prove that something is true for n, we use the fact that it was true for n minus 1, right? So we use the fact that it was true for one number to show that it's true for the next one. Now, strong induction allows us to use more information. So instead of using just the previous case, we are allowed to use all the previous cases. So the idea is that suppose that whenever all dominoes before a given domino have fallen, then that domino also falls, right? So suppose that whenever all dominoes before a given domino have fallen, then that domino also falls, and suppose that the first domino falls. Then every domino must fall. And so the difference is that a domino does not only depend on the one right before it, it may also depend on several previous dominoes. And so that is the intuition behind strong induction. And so let's state the principle. So to prove a statement P of n for all integers n, it is enough to verify two conditions. So first, the base step. So we prove that P of 1 is true. So we show that it's true for 1. And second, the inductive step, or I guess the strong inductive step. And what we do is, for every positive integer k, we assume that P of 1, P of 2, all the way up to P of k are all true, and then we prove that it's true for P of k plus 1. And so this is different from ordinary induction. In ordinary induction, we only assumed P of k, but in strong induction, we assume all the previous cases, P of 1, P of 2, all the way to P of k. And so this is useful when the proof of the next case may need more than just the immediate previous case. So the structure is, you prove the first case, and then show that if all earlier cases are true, then the next case must also be true, and that is strong induction.